Start recording. Okay, so today we're going to pick up where we left off last class. So we left off on a pretty basic example for an if conditional. So we're going to pick up from that same spot. Oh, actually, before we get started, last night I made a video for something that will hopefully help you with the project. So I had a question on how to deal with, let me share my screen. I got a question on how to deal with basically the results for your project changing over time. So if I open up our deliverables handout, so I got a question on basically so some of the stuff changing over time. So remember, the last date that I want you to include for the project is November 6th. So you can see that right here. So there could be a case where, let's say like Argentina here, that instead of being in the top 5 for the total amount of cases, by November 6th, maybe some other country is in that spot, and Argentina maybe drops down to 6th or something. So I think a lot of you, at least I'm assuming, and well, it kind of seems like this, that a lot of you are typing out parts of your code where you're actually writing the names of the countries yourself to like get their indices or something like that. And because you're doing it this way, you have to kind of update your code manually for new dates. So that can, become a lot of work as we progress on and we go to, like let's say November 6th, and you would have to redo a lot of your code if you're writing out the names of these countries and counties by yourself. So you can update, all your graphs depending on which counties or which countries are in the top 5. So if you're doing it that way, it takes a lot of time. So I made a video last night to kind of not an example for the project. I'm using different data, but I made a video how to show you for how you can do this kind of automated, where I never specify any names myself, but my graphs can update kind of automatically to kind of factor in which, in this case, which countries are in the top 5. So basically, doing these kind of methods that I go over in the video, if I update my spreadsheets with new data, I don't need to edit the code at all. All I have to do is just press run, and then all of my graphs are updated accordingly. Now I'm not using any for loops. I'm going to show you guys once we talk about for loops, and after your project is due, I'll go over actually this project using for loops, and basically that code will be a lot shorter. But this video that I made, it's not using any for loops. I'm just writing the code in a way where I don't have to specify any county names or country names myself. I don't need to specify the end date. Everything is kind of automated. So if that doesn't make, I don't know if I'm explaining it too well right now, but basically I'm not putting any names. That's the main kind of takeaway here. So my legends are populated automatically. My text labels here, my tick labels, they're populated automatically. I don't need to specify which countries are in the top 5. MATLAB does that all by itself. So I made that video, and I need to re-render it because it looks kind of bad. So I'm going to re-render it after class, and then I'm going to upload that. And that should hopefully help out. Okay. So any questions on that? I'm going to do that right after class, though. Yeah. Okay, so let's pick up again where we left off. Okay, so we left off on this example here. So this code right here, this will be for in a few slides. Okay, I'm just gonna add in a title here. I can never remember the date, 28. Okay, so let's actually go back a few slides just for some kind of review here. So we're going to be going over the if statement, the else statement, and the else if statement for all of today, basically. So in everyday life, we kind of go over some of these kind of basic forms of an if, else, and else if statements. So basic example here is if I took an exam and I kind of tell myself if I get an A on my exam, I'm going to drink beer. Else, if I get a B on my exam, I'm going to have ice cream. Otherwise, so if I don't get an A or a B, I'm going to cry. So that's kind of in just a sentence kind of format, and we can change this format into this kind of structure here, where we can just kind of see this kind of laid out in a more logical or easier to read manner. So if I get an A on my exam, I'm going to do this. Else, if I get a B on my exam, I'm going to do this. Otherwise, I'm going to cry, and then we end this entire statement here with a period. So in this kind of format, we have these indentations that kind of correspond to each condition that we have. So I have my first condition here, then I have this formatting. Now on this line, line 3 here, I have a whole new condition, and then I have this indentation to correspond to that statement. And then the last part I have otherwise that just encapsulates every other kind of condition. And then we also have a corresponding indentation. Okay, so these if, else, and else if statements, they're going to be able to help us basically make decisions in our program. So we don't need to actually, again, kind of do things manually. MATLAB will take care of it for us if we specify some condition. So if some condition is met, MATLAB will do something. If it's not met, it will do something else. And then our equivalent here for a period is going to be our end statement. Okay, so actually seeing this in kind of MATLAB syntax, this is going to be basic form for our if statement. So if some logical expression that we have, statements, so do something, and then end. So every if statement that we have, it's going to have an accompanying end statement. You need to make sure to include that. If you don't, MATLAB is going to give you an error anyways, and it will tell you that you're missing an end statement. Okay, so let's redo our example from last time. So let's say that we want to compute the square root of some number if it's greater or equal than 0. Okay, so let's first specify some variables. I'm going to put in c equals 25. And then below this, I'm going to have my if statement, or my if statement. So if c is greater than or equal to 0, now we're going to specify what we're going to do. So I'll say d equals the square root of c. And then I'll put end. Okay, so we've specified our variable. So if c is greater than or equal to 0, if that is met, then our line or our code on line 10 that's going to run. So MATLAB is going to compute the square root of c and assign that to our variable d. So if I run this, then we get an answer of d equals 5. So that ran because our input variable of c, that was 25, that's greater or equal to 0. Greater than or equal to 0. Okay, so if I change this now to something like -5, and I run that, then nothing shows up in my command window. So if I type in d, it says unrecognized function or variable d. So our condition up top here, if c is greater than or equal to 0, that was not met this time because c was -5. So that was less than 0. So because of that, we can't run our code here on line 10, so there's nothing that can be done. So MATLAB just doesn't do anything. So once I type in d, it says unrecognized function or variable d. So if I wanted something to occur, I would have to use an else statement. which we'll talk about in a few slides here, or maybe it's like right now. No, in a few slides. Okay, so let's just do one more example. Let's do 0. So because 0 is greater than or equal to 0, it's going to compute the square root of 0, which of course is 0. Let's do 4. What should we expect? We should expect an answer of 2, which we get. Okay, so that's the very, very basics of an if statement. Any questions on this so far? Okay. All right, just making sure it's recording. Okay, so if statements, they can also be nested. So this was what I first had in the beginning of class here. So my example in the slides, I'm actually changing here because that's really not a good example in the slides. So if I open this up here, this is our syntax. So if logical expression 1, do something, and then I have a nested if statement here that'll be related to our top if statement up here. So if logical expression 2, statement group 2, and you see that we have 2 if statements, so I need to have 2 end statements as well. So if you look at my example in the slides, I have if a is greater than or equal to 0, c equals a plus 5, and then in my nested if statement, I have if b is less than 0, then d equals the square root of c. So I'm going to change this example to have this second if statement be directly related to our first if statement. And that'll, basically make more sense for why we're using a nested if statement. Okay, so let's go over the example that I kind of wrote out in MATLAB. So everything is the same except I changed our nested if statement. So first we have if a is greater than or equal to 0, we're going to compute a plus b, and we're going to assign that to a variable c. And now from that result, now I have my nested if statement that's related directly to our result from our first if statement. And this says if c is greater than or equal to 16, then compute the square root of c and assign that to a variable of d. Okay, I'm going to change this to e instead of d. Okay, so right now we have a equals 20 and b equals negative 5. So if a is greater than or equal to 0, so we have a equals to 20, so that's good. So we're going to compute c equals a plus b. Okay, and so we get 15 because we have 20 plus negative 5, that equals 15. Okay, and then now our nested if statement that's based on that result that we just had right there. And this says if c is greater than or equal to 16, to compute the square root of c. Well, c equals 15, so this shouldn't do anything then. Let's find out if that occurs. Oops. Okay, and nothing occurs. So I still have c up top here because that was related to my first if statement, but if I type in e to the command window, it says that there is an unrecognized function or variable e. Okay, so this second if statement, this nested if statement right here, that condition wasn't met because c was 15 and wasn't greater than or equal to 16, so I couldn't compute the square root. Okay, let's just change this up a bit. Okay, I want to put 5. Okay, so now I have, I'm changing my nested if statement to say if c is greater than or equal to 15 to then compute the square root of c. Okay, so we had c equals to 15. Well, 15 is equal to 15, so that's now met. And now we can compute the square root of C, which is 15. That answer is 3.875. Okay, let's change this a bit again. I'm going to change b to 0. Let's do this to 25 too. There we go. Okay, so this time I have a equal to 25 and b equal to 0. So if a is greater than or equal to 0, is that met? Yes, we have a equal to 25. That's greater or equal to 0. So c equals a plus b. In this case, we have 25 plus 0, so that's 25. And then our nested if statement says basically is c greater than or equal to 15. 25 is greater than or equal to 15, so that's good. So now we're going to compute the square root of c. In this case, that was 25. The square root of 25 is 5. Okay, does that make sense?
Yeah, it does.
Okay. Okay, good. Okay, so we're kind of doing some basic examples here, but later on, we can start using these if statements to, not just calculate, some math operations here, but do other things like you could imagine that we could use an if statement for a project or some of the other examples that we've gone over in class. Okay, so now we're going to go on the cover the else statement. Okay, so I kind of mentioned the else statement a bit in some of these slides, I think. Yeah, like in this kind of introductory slide. But we're going to be a little more explicit about it now. So we can use the else statement and the else if statement, and we're going to discuss that in a few slides. We can use these when we want more than one action to occur based on, or there's a possibility of more than one action that can occur as a result of a decision. Okay, so the structure here, it's going to be the same. We're just kind of adding something on. So we have our if statement. So if logical expression, if that is met, then do something in statement group 1. So that's just like this slide here. If this condition is met, then we are going to compute the square root of c. If it's not met, then MATLAB won't do anything. So here, we're adding on this else statement. So if the condition in our first logical expression is not met, then it's going to do whatever is specified in statement group 2. So if we go back to this slide, let's say that c was not greater than or equal to 0. We could add on an else statement here to do something else. And this time, or in this case, we wanted to get, an undefined variable for d. We could say, if c is greater than or equal to 0, d equals square root of c, else d equals, I don't know, c squared. And then that would work for us. Okay, there's a question. Where should we put the semicolon when using the if statement? Yeah, so you don't need a semicolon. So if c equals greater than or equal to 0, we don't need to put any semicolon up here. Okay. Okay, and then here is a flowchart. So usually I don't like flowcharts, but this actually is, I think it's pretty good. So this just kind of shows what I just said in a more visual kind of format. Okay, so we have if, and then this is our logical expression. If this is met, then we're going to do something in statement group 1. If this logical expression is not satisfied, then this is kind of our else statement. We're going to do something else, which will be statement group 2, and then we're going to end our script. Okay, so we got an example now. So we have if x is less than 10, then compute x squared. If it's not less than 10, we use our else statement, and we will compute basically the cube of x. So we're going to do x cubed. Okay, so let's do this. I'm going to suppress my outputs here.
Professor, for the ends, does it matter how lengthy they are, or can they be like overlap each other?
Does it matter what?
So for the you have the ifs and then something, some code, and then if some code. But then on the bottom where you said e square of c, there's n, and then n is a little bit to the left. Does it matter how spaced out it is, or it doesn't really matter? Or it's just more like you can read it better?
I think technically it doesn't matter, but you should have those tabs. And you see, I get an error here. It says that it's not aligned. So yeah, we want to align them because it's easier to read, kind of which code corresponds to which if statement.
Okay.
And it automatically gives those those spacings.
Okay. Cool.
Okay, so we're gonna go over this else example now. So I'm gonna put in x equals to 5, and we'll change this as we kind of go through this example. Okay, so we're gonna do if x is less than 10, y equals x squared, else y equals x cubed. You also notice that I typed in else and then I went to a new line. If I didn't do that, I would get another kind of warning where it says that I should put whatever kind of statement here on a new line. So my script would still run if I had code on the same line as else, but we're going to put it on a new line again so our code is easier to read. Okay, so let's look at this code. We have if x is less than 10, we're going to compute x squared. So x right now is 5, so that's going to work for us. Okay, first I'm going to go over this example, then I'll look at the question in the chat. Okay, so x is 5, that's going to be less than 10. So we should expect that we're going to get y equals x squared, so y equals 25. Let's see if that happens. And yep, we get y equals to 25. Okay, I'm going to look at the chat. Okay, so your code should still work if you have a semicolon at the end of the line where I have e equals square root of c. If I type an e right now, then I get a result. If you put a semicolon, basically what it does is it's suppressing the output to not show up in the command window. Your code should still run though, so if you type an e in the command window, you should get, for the numbers that I have up here, a result of 5. If that still doesn't work, then you probably had some formatting or syntax issue above. Okay. Okay, so let's do one where we have, where x is greater than 10. So let's do, there's not really any good numbers for this. I'll do 15. Okay, so this time we have x equals 15. So if we go to our first if statement, we have if x is less than 10, compute the square. That's not going to be satisfied. So we're going to say else y equals x cubed. So now we're going to do 15 cubed. If I run this now, let me do that. Then we get y equals 3,375. We can check our work by doing 15 times 3, or not 15 times 3, 15 cubed. And that's 3,375. So our code worked here. So it didn't compute the square, or it didn't do 15 squared because 15 is greater than 10. So it MATLAB did the statement that corresponds to our else statement where we have y equals 15 cubed. Okay, and then I just have this example here. So if 10 or if x equals to 10, that's also going to do 10 to the third because 10 is not less than 10. Okay, so does that make sense before we go on to the next example? Okay. Also, I don't know why I just thought of this, but I don't know if anyone saw the game last night with the Dodgers winning. I'm fine with them winning, but I wanted the Rays to win. At least take it to Game 7. Yeah, finally gonna choke. Yeah, I think there was like an ad or something, a commercial after they won with Kershaw. Like they showed him in the past few years, like really, really sad when they choked, and he could finally celebrate. Okay, so let's go over this example. This is going to be kind of an in-depth example here. Okay, so we're basically going to take note of our code structure. And yes, no Astros this year making trash cans. Okay, so we're going to go over or take note of our code structure. So again, this is going to be, a bit. So let's just get started with it. So basically, the main thing that we're going to go over here is basically the order of our statements that we have for our if statement and our else statement. The code structure example. Okay, so the first thing we're going to have is x equals -4. Of course, you don't need to have the brackets, right? We don't have a vector. It's just a scalar right now, so I don't need to have brackets. So if x is less than 0, we're going to use a new command. So I put a semicolon on this line. I don't need that though. So if x is less than 0, display, this is a new function that we're going over. Display some values are negative. So this display function, it's simply going to display whatever we put in our argument here. Now this is only going to occur if x is less than 0 because we're using this as our statement that corresponds to our if conditional or if statement. So if I run this right now, because -4 is less than 0, we're going to see in our command window some values are negative. And we get that right there. Okay, so let's see. Yep, so we talked about everything here. So this worked as we kind of expected. X was -4, that's less than 0. So our command for display some values are negative, that's going to show up in our command window. Okay, so now we're going to change x. We're going to make this a vector now. So we have x equals -4, 5, and 9. So if I run this code, I run that, now nothing shows up in the command window. So why do you think this happens? You're going to put something in the chat. Yeah, why don't we do that? So why do you think that happens?
Because two numbers aren't negative.
Okay, yep, I guess that wasn't very challenging. Yeah, that's right. Okay, so because not all of the numbers in our vector x, not all of them were less than 0, then this expression here isn't satisfied. If x is less than 0, that needs to occur for all of our values in our vector x. Okay, so basically what we're doing here, if x is less than 0, we have basically a logical expression. So really what we have is x equals 1, 0, 0. This kind of corresponds to our logical answer. So we have x is equal to -4, Is that less than 0? Yes, so we have a 1. And then our numbers 5 and 9, they aren't less than 0, so that logical answer is a 0. So because our entire vector x is not less than 0, we can't display some values are negative. Now that seems kind of contradictory here because I'm implying that my code could realize that there's only some values that are negative and not that so you would expect from this code that it would show that this would still show up, right? Because only one value here is negative. But MATLAB is doing this based on this kind of logical expression where not every value in x was negative, so nothing showed up. So we're gonna basically try to fix this. Okay, so we're gonna modify our example, and again, we want to get to a point where even if I have an array here with different numbers, it could still show or display in our command window that some values are negative. You know, if we had a case like this where x equals -4, 5, and 9. Okay, so before we do that, we're going to add on an else statement. So we have if x is less than 0, display some values are negative. Else y equals x squared. Oh yeah, okay, I'm using dot notation here because really we have a vector. You know, ideally we would go element by element. In that case, we would have to use a for loop, which we'll talk about probably next class. So right now I have x dot squared because again x is a vector, so I have to do it. This way. Okay, so if I run this now, then again nothing showed up in our command window because this wasn't satisfied for the entire vector x. So it's not doing or actually if I type in, let's run this like this. There we go. So if I run our code like this, then we see that our output is y equals x squared, and that's doing it for each element here. That's why I added dot there. Okay, so why did this happen? So I have if x equals, or if x is less than 0, display some values are negative, else y equals x squared. So we would expect our code to only find or to only do 5 squared and 9 squared because those are positive values. But it also did this for x equals -4. So this again occurred because if x is less than 0, display some values because this condition wasn't met because not every value was less than 0. Because that wasn't met, MATLAB isn't going to act on this. So it goes to our else statement, else y equals x squared. So it does it finds the square for each number in our vector x. So again, what we would want to have, you know, ideally this would show some values are negative and it would only do compute 5 squared and 9 squared. But that doesn't happen, so let's continue to work on this. Okay, and then everything in my slides, that's what I just went over. Okay, so now what we're going to do, we're going to rearrange this to first have if x is greater than or equal to 0, then it's going to compute y equals x squared. So that's basically the same thing as what our code did here, but we're actually going to have y equals x squared as our first statement. So I'm going to comment all of this out just so we can keep it there. So now I have if x is greater than or equal to 0 to compute y squared. Or x squared, sorry. So y equals x squared. And then I'm going to say else display some values are negative. And then end. Okay, so if I run this now, well, let's first think about what's going to happen in this case. So we have if x is greater than or equal to 0, y equals x squared. So we would expect in this case to only only do 5 squared and 9 squared. And then it should display some values are negative. Is that actually going to happen? It only shows some values are negative. Okay, so it's doing this again. It's the same kind of thing. Not all of our values in x were greater than or equal to 0. So because that wasn't satisfied, we don't see any output for our variable y. Okay, so then it goes on to our next kind of argument here, which is display some values are negative. So it displays that. So we're a little closer to what we want, but we're still not quite there. So did that make sense? I think it was maybe a little convoluted. Okay, but we have, I'll just go over this one more time. So hopefully I can reiterate what this code is doing. Okay, so in this format here, we have if x is greater than or equal to 0 to compute y equals x squared. So intuitively, we would think that this would only compute y equals x squared for our values of 5 and 9, because those values are greater than or equal to 0. So we would expect to see y equals 25 and then y equals 81. That's what we would expect, but we don't see that because MATLAB is it's only going to run this if all of the values in our vector x were greater than or equal to 0. So that's not met, so MATLAB isn't going to do anything for our variable y. So then it moves on to our else statement, which is display some values are negative, and of course that shows up. Okay, so now what I'm going to do is I'm actually going to make our code work as we would expect it to work. However, to do that, we have to use for loops. So I'm going to kind of, of course, we haven't gone over for loops yet, but I'm going to use a for loop here just to show you that we could get our code working as we would kind of expect it to work. Yeah, they would all have to be true for y to run. That's correct. We can do that right now too. So now I'm going to change this to x equals 4, 5, and 9. Now if I run that, then you see that y that does run, and it computes 4 squared, 5 squared, and 9 squared. And then because all of them are positive, it doesn't display some values are negative. Okay, I'm going to change this back to -4. Okay, so now I'm going to make this block of code here to actually, again, run like we would kind of expect this to occur. So I'm going to have for I equals, so don't worry about my syntax here. This is really just to show you that we can get the code working. So for I equals 1 to the length of x, if x vi is greater than or equal to 0, so this line of code is going through each element in our vector I, or our vector x, then y sub I equals xi squared, else display some values are negative, and let's do this. I think I messed up somewhere. Oh, I know why. It's taking this value because we had y earlier on was 1000 right here. So let's comment out this code. I'm just going to comment out everything just to be safe. kind of an annoying aspect. Okay, so there we go. So now our code, it runs like we would expect it. So I'm going to do this. I'm going to type in y. And there we go. So right now we have x equals -4, 5, and 9. So if we go through this, I would expect this to only show y equals 5 squared and 9 squared. And then because we have x equals -4, I would also expect it to then display some values are negative. So right now our code is working how we expected it to work. We had x equals -4, so MATLAB should display some values are negative, which it does. And it should only compute 5 squared and 9 squared, which it does. We see that y equals 0, that corresponds to -4. It shows a 0 because, it first does a logical kind of answer. So -4 is not greater than or equal to 0, so we get a logical answer of 0. Okay, so I just wanted to show you that we can get the code working to how we would expect it to work. But it's okay that, you don't need to fully understand this code here, at least quite yet, because we're using a for loop. Okay, alright, so let's go on to the next example. I would typically ask if there's any questions, but I'm sure there are, but that's just because we never went over for loops. Okay, so now we're on the else-if statement. So here is the syntax for else-if statement. Okay, so we're going to add on our else-if statement to the structure that we've worked on so far here. And this is going to give us the most general form for our kind of if structure. So here we have if logical expression 1, then do something. Else, if logical expression 2, do something for that. Else, do something. So basically, in I guess more easy or normal conversational terms, if logical expression 1, if that is met, then we're going to do something based on that condition. Else, if logical expression 2, if that is met, then we're going to do something based on that. Else, so if neither logical expression 1 or logical expression 2, if neither of those are met, then we're going to run statement group 3. Okay, so if logical expression 1 is met, we're going to run statement group 1. Else, if logical expression 2 is met, we're going to run statement group 2. If neither of those were met, we're going to run statement group 3. Okay, so let's do an example. Before that, this is another flowchart. So we see if logical expression 1 was met, we're going to do something, and then we're going to end our script. If it was not met, we're going to run our second conditional statement. If logical expression 2, if that is true, we're going to run statement group 2. If that is not met, we're going to run statement group 3. Okay, so let's do an example here. Oh geez, we're already almost done with our slides. I thought this would take a lot longer. That's not good. Okay. Alright, so else if statement. So we're going to do this in 2 different ways. We're going to do it a longer way and then a shorter way. Okay, so I'm going to type in z equals 9. And then we have if z is greater than or equal to 5. Then we're going to have our first statement group there. So if z is greater than or equal to 5, then y equals z squared. Then else, if z is less than 5, then y equals square root of z. And end and end. Okay, so you'll notice that I didn't use the else if statement yet. We're going to do that in our second kind of version here. Wow, my webcam is really laggy. I just noticed that. I don't know if it was laggy the whole time or not. On a side note, I'm using my webcam is plugged through OBS right now because it's better quality, but yeah, I guess we got an issue here. It's extremely laggy. What if I'm gonna quickly try something. Still laggy. Oh well. Okay, so let's go through this now. So if z is greater than or equal to 5, we're going to do y equals z squared. So in this case, we would expect this to be an output of 81. Let's run our code, and that's what we get. So now let's change this to 4. So this time, z is not going to be greater than or equal to 5. So this statement group right here isn't going to run. So MATLAB is then going to go to else. If z is less than 5, then y equals the square root of z. So this time, this is going to run, so we should expect an answer of 2. And that's what we get. Okay, this is really bugging me how laggy my camera is. I gotta attend to this. Okay. I think it's better. If it's not, oh well. I can't really see my webcam because my chat's blocking it. Okay, so let's go on. Sorry about the tangent. Okay, so now we're going to do this in a more compact way, because here we have a few lines here, and when we're writing code, we want to be lazy/efficient. We want to use as little lines as possible. So let's comment all of that out, and then we're going to run this same code in a more compact way. So I'm going to do if z is greater than or equal to 5, then compute y equals z squared. So this part is the same. But then I'm going to use our else if command that we just talked about. So else if z is less than 5, to then compute y equals the square root of z, then end. Okay, so really we're doing the same kind of thing. You can actually kind of visually imagine what we're doing here. Here we have else if, so we're just kind of putting this on its own line. And because of that, I also don't need to have another end statement. So this is it's doing the same thing as our code that was commented out up here, but it's doing it in a more compact and efficient way. So if I run this code, well, we get the same thing. It's y equals 2. Let's change this just so you know I actually changed it. We'll do 3. There we go, y equals 1.73. Let's instead do something like z equals 9. So, oh, we already did that. We'll do z equals 10. And then if I type in y, then we have y equals 100. Because 10 is greater or equal to 5, greater than or equal to 5, we have y equals 10 squared. All right, any questions on this one?
I'm having trouble because I did what you did and I put. Oh wait, hold up. Think I'm missing something. Maybe the 10. I'm not sure because when I ran the first method, it ran okay, but the second method's not running for some reason.
Okay, yeah. Did you comment out z up here? Make sure that's not commented out, and then it should run.
How come you only needed to put one end?
Just because else if that doesn't need an end statement. I know that's it's a bit different. But if I had another if statement, kind of like we had above, then that needs a corresponding end statement, but else if doesn't, just like else, that doesn't need an end statement. That's kind of the same thing as else if.
Okay.
So more ifs we have, the more ends we have. The less end ifs we have, the less end we have. Right?
Yeah. Mm-hmm. Okay, so there's a question in the chat. So Min, we can talk about that after class if we have some time for how to check that. Okay, so now we have a kind of a longer example here. So I'm gonna comment all that out. I'll comment this out too. Just so I don't run in the same issue as before, we're gonna make a section here. If, else if, else example. Okay, so I'm gonna do m equals 25, and if m is greater than 10, t equals the square root of m, else if m greater than or equal to 0, t equals the natural log of m. So remember in MATLAB, log is actually natural log. If we want to do log base 10, then we would do log 10. Else t equals m, and then end. Okay, so let's I even added some more stuff here. Okay, so we have if m is greater than 10 to compute the square root of m. So here we have m equals 25, that's greater than 10, so we should expect our answer to be t equals 5. If we run it, then that's what we get. Then we see else if m is greater than or equal to 0, so really this is this kind of expression here. Our first, I guess 4 lines, they're going to see first if m is greater than 10, and the next thing it's going to do is check if m is within our range from 0 to 10. Else, if none of those conditions are met, then we're going to have t equals to m. Okay, so if m was less than 0 basically, then t would be equal to m. Okay, so here we have m equals 25, so again that's greater than 10, so we're going to compute t equals to the square root of m, so t equals to the square root of 25, which is 5. Let's change this to something like 4. So this is gonna do if m is greater than 10. Is that met? No, it's not. Else if m greater than or equal to 0. So now this is met. So t should be the log, natural log of 4. So if I run this and we get t equals 1.38, we can check this by doing log of 4. And that equals 1.3863, so that works. I'm going to do one more example here where we have m equals some negative number. So let's do like -2. If I run this now, let's uncomment that, or unsuppress it, then I get t equals -2. So I have t equals to -2 because our 2 if statements up here, they were not met. So -2, that's not greater than 10, so we're not going to compute this. And then 2 is not greater than, or -2 is not greater than or equal to 0. So we're going to go to our else statement, which is t is equal to m. In this case, t equals -2. Okay, we have another comment. Okay, so once it finds the one that it is true for, it won't move on to the other statements and just end there. Yes, that's correct. Okay. Okay, and then here I just talk about what we have. Or no, I'm going to add on some stuff. That's right. Okay, so here we still have our code, but we're just going to add on some else if statements. Okay. Yeah, I'll just do it down here. Okay, we have m equals -5. So here we basically have all of the code that I just had here, but I'm going to add a nested if statement and a corresponding else if statement. Okay, so we have if m is greater than 10, t equals the square root of m, so that's what we just had up top. And then we have a nested if statement, so if m is equal to 36. Actually, yeah, it should be nested. Yeah, it's correct. So if m equals 36, t is going to be equal to the square root of m plus 4. Then we have else if m equals 49, t equals the square root of m plus m. And then we have an and, then we have an else if m is greater than or equal to 0. Don't worry, I'm going to break all of this down. T equals log of m, or natural log of m, else t equals m, and end. Alright, let's go through this. So the first thing we're going to do, I want to do what I actually have in my slides. Okay, we're going to do 36. Okay, I guess I should suppress some stuff actually. Checking my code, making sure I put it in correctly. Okay. Okay, so we have m equals to 36. Okay, yeah, I see what it's doing. Okay. Yeah, I know I have double equals. That it should be that way. I'll go over that. Okay, so we have m. If m is greater than 10, so that's what we have. We have m equals to 36. So it could do t equals square root of m, which it probably did in the beginning, which is yep right here, t equals to 6. But then we're going to go down here and say, actually check if m equals to 36. Maybe I should have structured this a bit differently. Like maybe I should have put this before. But it's okay. Our code still works like we want it to. So at first, because 36 is greater than 10, it first computes t equals the square root of 36, which is 6. That's why we see t equals 6 right here. But then our code says if m equals 36, so I have two equal signs on purpose. I'm not assigning m to 36 here. I already did that above. So I'm using a logical operator here, which is the equal sign. So if m is equal to the value of 36, then MATLAB is going to compute t equals the square root of m plus 4. So that's doing the square root of 36, that's 6, and then plus 4 is 10. So that's why we have our final answer here of 10. Okay, I'm going to actually start suppressing some stuff, just so I don't see all of the output here. Okay. Okay, so again, we can kind of go through this one more time. Our first line is going to check if m is greater than 10. We have m equals to 36. So it'll first do t equals the square root of m. That'll be 6. But then MATLAB is going to look at our nested if conditional here. So it's going to see if m is equal to 36, which it is. Then it's going to compute the square root of m, so 6. And then it will add 4, which will be 6 plus 4 is 10. Okay, and since that was met right there, then all the other stuff here is not going to matter because it's not equal to 49. And down here, all of this stuff doesn't matter because our condition was met in this line right here. Okay, so let's change this to a different number, and we'll start kind of going through all of our other conditional statements that we have. Okay, so we have m equals to 49. Why doesn't it like this here? Oh, I need an else if, that's why. There we go. Okay, so here we have if m is greater than 10, 49 is greater than 10. So the first thing it'll do is compute the square root of m, that's 7. But we don't want that. We're going to go down here. It's going to check if m is equal to 36. It's not. So then it's going to do else if m is equal to 49, which we have. It'll do t equals the square root of m, so 7. And then it's going to add our value of m, which we had 9. So if I type in t, then we get 56. Okay, and since we satisfied this right here, our script is going to end right there. We have double equal signs because we're doing a logical operation. So we're not assigning a variable of m equals 36 or m equals 49 down here. I already assigned the value for m up here. So the double equal signs, that's a logical operator. So MATLAB's going to check if m was actually equal to some value. So it's going to check if m is actually equal to 36, then it's going to run this code. If it's not, it's going to see if m was equal to 49, and then it's going to run this code. If it's not equal to either of those, it's going to start going to this statement down here. And we're going to go over that right now. I guess I didn't put in an example here. That's fine. I'll put one in. So let's do m equals 5. So is m greater than 10? No, it's not. It's 5. So we're going to skip everything in here. We're done with this conditional. So then we're going to go down to else if m is greater than or equal to 0. Now that is met. 5 is greater than or equal to 0. So we're going to get t equals the natural log of 5. Type in t, there we go, we have 1.60, and we can double check this by doing natural log of 5. Again, remember in MATLAB, the natural log is specified by log. Log base 10 would be log 10. Okay, so the natural log of 5 is 1.6. Good. Now let's do one that's less than 0. So we'll do m equals negative 5. If I run this, what should we expect? T equals negative 5. So negative 5 is not greater than 10, so none of this is going to run. And then we have else if m is greater than or equal to 0. Negative 5 is not greater than or equal to 0. So we're going to go to our else statement, which is t equals m, so t equals negative 5. Okay, any questions on this? If we didn't put t equals square root m below the m greater than 10. Oh, what if we didn't do that? Okay, so then I think it would just go to our else statement. Let's comment this out. So, first it's going to check if m is equal to 36 or if m equals 49. So let's do 15. Okay, so yeah, it's actually not going to do anything. Okay, so let's break this down. So we have if m is greater than 10, 15 is greater than 10, but I didn't specify what it should do here. There's nothing here that shows what it should do because it's not equal to 36 and it's not equal to 39. So then we have our else if, which is if else if m is greater than or equal to 0 to do something. But our condition was first met because we have if m is greater than 10. But because I didn't specify what to do, it didn't run. Or it ran, but MATLAB didn't know what to do. Does that make sense, Kevin? Alright, let me know if that didn't make sense. Yeah, okay, so if we change this to 36, then now what we should get is, our answer should be 10. So let's see, and then yes, our answer is 10. Okay, because now it's checking. First we see if m is greater than 10, 36 is greater than 10, and then it goes down to if m is equal to 36 to then compute the square root of 36, which is 6 plus 4 is 10. Okay, yeah, this line here, the square root of m, that's going to be used for if m is not equal to 36 or 49, but it's greater than 10. So if it's 44, then it's going to compute the square root of 44. Okay. Okay, let's see what we're... Alright, we are going to make time. Okay, so the last thing we're going to do today is put in some more Elseif statements. So right now, I only have one Elseif statement, but if I want to check some other statements here, or conditions, I could also add those in. And actually, let me move this line of code down, because I think really it should be down here. Alright, maybe I need to think on this a bit. Let's see if this works. Yeah, that didn't work. Okay, I'm going to think on that later. So it does work up here, but I don't think this is actually the most efficient way to actually run our code. Okay, but let's go through our example here. So right now I have one else if statement, which is else if m is equal to 49. But we can keep adding other else if statements if we want. We can add as many as we want if we want to check some other conditions. So I'm going to add in else if m is equal to 81 to compute something. So t equals the square root of m plus e t. So e to the t. Alright, so let's change our code now to m is equal to 81. Okay, so now if I run this, we first check if m is greater than 10. 81 is greater than 10. So initially it's going to compute the square root of m. Let's actually unsuppress these two. So it computes the square root of 81, which is going to be 9. And then it's going to check if m is equal to 36. It's not, so it's going to go down to our else if statement. M is not equal to 49, so it's not going to run this. So then it's going to go down to our next else if statement. And at this point, it sees that we had a value of m that was 81. So 81 equals 81. So now it's going to compute the square root of m, which again is 9. And then it's going to add on e to the t. So in this case, it's going to do plus e to the ninth power. And I kind of break that down here as well. Okay, so it's doing, it's going, I guess we can kind of reiterate what I just said. But behind the scenes, we have, first it's going to see that 81 is greater than 10. So that's good. So it's first going to compute the square root. And then it's going to check our other nested conditionals that we have. Then it's going to see that m does equal 81. So then it's going to compute t equals the square root of m, which is 9, plus e to the ninth power. and that'll give us 8,112. All right, and then I can of course change this to do, I don't know, I can add in another Elseif statement if I wanted. So we'll do Elseif T, I don't know. We'll do like, maybe not that. We'll do T greater than or equal to 0. T equals, we'll do M squared. We'll do that. So now let's try to put in M equals to 4. All right, this isn't working how I wanted it to, actually. Let me go back in my slides a little bit. Yeah, okay, I wanted to do it like this. Oh, it's because of this right here, that's why. All right, so I would have to do something else. I'll just add on just for time's sake. Add on t is equal to, so by the way, that code didn't work. What I was expecting was this to compute t equals 4 squared, which would be 16. But we're getting t equals 1.38 because it's actually going down here and it's updating our value for t by computing the natural log of 4. So if I do log 4, then that's 1.38. So if I didn't have this, I'll actually comment this out. Then it should run how I expected it to, and then it does. But we can add on another Elseif statement if we so choose. So I'll do if t is equal to 44, then compute m squared. Nope, still not working how I wanted it to.
Is it because at the beginning you have 2 ifs instead of else if?
No, because this is nested, so this should be fine here.
Okay.
Yeah, okay, this one isn't working how I wanted it to. So I'll look at this after class and then I'll post an update on Canvas, but we're out of time. So what this should do though is compute 44 squared. So I'll have to debug my code and figure out what's going on. Oh, yes. Thank you. Yeah, it should be 2 equal signs 44. And yeah, there we go. Thank you. So, and then we can double check our work by doing 44 squared, and yep, that's correct. Yeah, it's always the little things that can really mess you up. Just changing that to an M, that's what it should have been. Okay, so basically we can keep on adding else-if statements either here, or we could have done it down here as well to, to put in any conditions that we want to check that can be satisfied or not. Okay, so we're out of time though, so at least we went over everything that we wanted to go over today. So next time we're going to start for loops. Okay, so I'll see you all of you on next Monday. So work on your project. If you have any questions, go on the Discord. And I'm going to post our video later today. That should help you on the project. All right, so see you guys next time. Yep, have a good day.
Thank you.
Have a good